So what we're going to do is we're going to change the base again. So I'm going to say now, let's say our base is, we'll do h of x for no reason at all. Let's say it's a half to the x. Let's say it's a half to the x. We're going to do the same things. And we'll again go -3, -2, -1, 0, 1, 2, 3. So what do we get? If we have a half to the 3 is a half times a half times a half, or 1 over 2 to the 3. That's going to be 1 to the 8, 1 over 8. A half to the 2, or squared, is 1 over 4. A half to the power of 1 is just a half. A half to the 0 is 1, because anything to the 0 is 1. A half to the negative 1 is going to be, actually, if you can check it in the calculator, it's going to be the same thing as the 2 to the -1 goes to the top. That's going to give 2, and that's going to give 4, and that's going to give 8. So if we go and we take a look at what this thing looks like. So at -3 we are at 8, at -2 we're at 4, at -1 we're at 2, then 0, then a half, then a quarter, and so on and so forth. And so this one is kind of like the other graph. So what this is now h of x, which is a half to the x. It's going to be kind of the same thing, but it goes down this way. Now, how is this different? Well, first, actually, how is it the same first? So it's the same in that we still have an asymptote, which is, again, a line that the blue line gets close to the red line. Usually when we draw an asymptote, but I haven't been doing it actually, but you're supposed to usually draw it as a dash. So usually when we draw an asymptote, it's usually a dash. So when the blue line gets close to the red line, but it doesn't quite touch it, so that's the asymptote. And that's going to be at y equals 0. What we notice about this one, though, is this one is decreasing across the entire domain. Right? It's going down, 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 and it keeps on going down. It keeps on going, and it gets closer, but it doesn't quite hit it. And I'm not necessarily going to go through it. I'm going to go through it. But let's say we had j of x equals 1/5 to the x. We're going to find that it's pretty much going to be the same as a half to the x. So -3, -2, -1, 0, 1, 2, 3. I'm on the screen, yep. And that gives us 125, 25, 5, 1, a fifth, a 25th, and a pretty small one, 125th. And if we graph this thing, if we graph j of x equals 1 over 5 to the x, it's going to be kind of like when we had 5 to the x, it's going to, when it goes up faster. So at -1, we're at 5. At -2, we're already at 25. We're already gone. That's at 1. That's at 5th. So it's just like the other one, but, oh, I missed. But it climbs up faster, hits the ground faster. Still, though, has the same asymptote. And like the 1 over 2 to the power of x, this one is decreasing. So if I was going to summarize in some fashion, the equation of an exponent is generally of the form y equals b to the x. There's going to be other stuff coming in, but for now we're just going to say y equals b to the x, where b is some base, like that. If b, and then b could be, let's do a number line. So if b is more than 1, so if b is 1.3 or 2 or 2 to the x, right? So 2 to the x was kind of over here. Then the graph looks like it's something that's increasing. So that's if it's between 1, 2, whatever. If it's between 0 and 1, then it's going to be decreasing. I'll kind of put some cutoffs over there. So it's between 0 and 1, it's going to be decreasing. So that, for example, was 1/2 to the x. So the base was between 0 and 1. And if it's negative, that's essentially a no-go zone. You can't graph those things. Those functions don't essentially, for a variety of reasons, don't exist. We are never, ever in this course going to consider any bases that are less than 0. So in this course, as far as we're concerned, all the bases are positive, and they're either between 0 and 1, or they're between 1 and